Okay, so here's a video on getting mean averages from frequency tables. So we've got some data here. If you're used to the Cambridge type syllabus, what they normally do is they will arrange these as rows rather than as columns, but it's the same kind of thing. It's actually slightly easier to work with the rows than sheets like this. But you might see revision questions which are formatted differently. Don't want you to get freaked out by them. They just look slightly different, but they're asking about the same sort of thing. Now, one really important thing to realise is this is looking at what number of plants fall in this range of heights. We don't know the individual heights of any of the plants. All we know is there are 7 plants that sit in this group of heights that we've decided upon. And so that's why it's actually an estimate of the mean height. The thing is, most of these could be either at the lower end or at the higher end. We don't know exactly, but it's a useful type of number that we can use to make like predictions or decide which is the best kind of seed for your plants or whatever. So the important thing then is looking at each of these groups. Well, what number do we choose? Do we choose 140 or 150? Well, we choose neither of them. What we go for is the mean average of the two, or the midpoint. So I'm going to quickly show you what you need to do for that, and then I'm just going to sort of shortcut the rest of them. To get the mean average, we just take these two, so 140 plus 150, and then we divide by 2. So that's going to give us 290 divide 2, which is just going to give us 145. Now, you may be like, oh, well, duh, that's obvious. That's the middle number in between 140 and 150. But it's not super obvious to everybody. And I tell you, it may seem obvious to you right now, but it may not be completely obvious when you're under the pressure of an exam. Also, there's a reason you need to be careful when you think about this. So 140, 150, grand, 145 is the average of those two, or the midpoint. There you go, 150, 160, our midpoint is 155. 160, 170, 165. 170, 180, 175, 180, 200. This is where you need to be careful, because what you might just do, if you're doing this robotically, if you're doing this really quickly without thinking about it, you may just write 185, but that is not the midpoint of those two, because this interval is twice the size of those intervals. That doesn't cause us massive complication though. We've chosen a bigger group. They put this in here to make sure that your attention to detail is good, because that's really important when you're doing mathematics. So what we have is 190. Cool. So we've done the first big chunk of difficult work in this. Then the next thing is we have to use the maths to show the relative importance of these groups. Now, the most important group, as we can see, for the mean average is this group here. And so that's going to affect it most, which means we multiply this by this, and that gives that large effect. In fact, we do the same thing for all of them. What we do then is we multiply the frequency by the midpoint for each of those bands. So that's what we're going to do. We're going to do 7 times 145 plus 10 times 155. I'm just going to shortcut that, 1,550. That's pretty easy. And then 15 times 165 plus 19 times 175 plus 9 times, do a brackets a bit curlier, 190. Now, these are all calculations which you could be expected to do using, like on paper. I think it's very unlikely they'll ask you to do that in an actual exam, because it's pretty tiresome, right? You're doing a whole lot of other stuff there, and it's annoying. Really, it's just grinding numbers, which nobody does anymore. That's why calculators were invented. That's why computers were invented. Anyway, so we're going to use this, so you're going to get from this 1,015. Then for the next one, 1,550, that's fine. We've already got that, 10 times 155. And then 15 multiply 165. So it's going to give us 2,475 plus 19 times 175 times 175. It's going to give us 3,325 plus 9 times 190. 9 times 190. So 1,710. And then finally, just for the sheer fun of it, we add all these numbers together. So it's going to be 1,015 plus 1,550 plus 2,475 plus 3,325 plus 1,710. And that gives us a total of, let's write this in the next line, 10,075. Now, what does this number actually mean? Well, this is very roughly the number we would have if we added all the heights of our tomato plants all together. So if we've got this number of tomato plants, whole bunch, add them all together, we get this about 100 meters. Okay? Now, what that means, why do I draw attention to that? Well, we want the mean average of the heights of all those tomato plants. So we've got the total height, and then we just divide by the total number of tomato plants. This question is a bit mean because it doesn't tell us the frequency. So what we need to then do is add all this together and get the total number of tomato plants. 7 plus 10 is 17, plus 15 is 32, plus 19 is 51, plus 9 gives us 60. They will usually give you a reasonably nice number to work with. So we divide 10,075 by 60. Again, this is something they will probably just give you, this would probably be in a calculator paper. So divide that by 60, and what I get from my calculator is 167.916667, or as a fraction, 2015 over 12. Okay, now what do we do with that? If in doubt, just leave it. Okay, if you're really not sure about how to write that any simpler, just leave it the way it is. But generally what they want is they want you to write it as 3 significant figures. There's our 3. And what we see is the whole number itself is actually closer to 168. So we write 168 than it is the 167. So there is our estimate for the mean average for those. Don't simplify it any further. Do not simplify it down to 2 significant figures. Because if we did that, what we'd have is 170. And that's not good enough. That's too crude. That is too broad of an estimate. Okay? Explain why your answer to part A is an estimate. It's something I mentioned earlier in the video. It's because we don't know the heights of any of the individual plants. They're actually grouped. Okay? So that's what I'd say. We don't know the heights of any individual plants. They're all grouped. There you go.